Question 1.4. We are given the reaction X plus Y reacts to form Z in an equilibrium, and we need to use the diagram to figure out the value for the heat of reaction as well as the activation energies for the forward and reverse reactions. On a potential energy diagram, we have potential energy on the y-axis and the course or progress of reaction on the x-axis. The first horizontal portion of the diagram is the potential energy of the reactants, which are X plus Y. This energy we can write as H reactants. The second horizontal portion is the potential energy of the product, Z, whose energy is H product. Notice that the energy of the reactants is higher than that of the product, and the difference between these two values is delta H, the heat of reaction or enthalpy of reaction, which is shown by the red arrow on the graph. Since the energy of the product is less than that of the reactants, delta H is negative, and the forward reaction is exothermic or energy releasing. So the answer cannot be C, which has a positive heat of reaction. Then the energy that needs to be absorbed by the reactants to reach a transition state is the activation energy of the forward reaction. Activation energy is the minimum amount of energy required for colliding molecules to undergo a reaction. And if we consider the reverse reaction, which is Z decomposing to form X and Y, we would need to read the diagram backwards. The activation energy needed by Z to form X and Y is given by the yellow arrow. This is the activation energy of the reverse reaction. Comparing the sizes of the arrows for the forward and reverse reactions, we can see that the activation energy of the reverse reaction is larger than the activation energy of the forward reaction. Only in answer D is there a negative heat of reaction and an activation energy of the reverse reaction larger than that of the forward reaction. So the answer is D.